Ever wondered how your phone or camera calculates distance to objects? It's all about depth imaging, those hidden 3D maps that tell your device how far a tree is or the shape of a coffee cup. But here's the problem. Real-world depth data is messy. Think of it like trying to watch a movie through a foggy window. Details get blurred, and it's hard to tell what's real. Traditional methods try to clean this up, but they struggle. Some process one frame at a time, which works for stills but fails with motion. Others stitch multiple frames together, but if the scene shifts, it's like assembling a moving puzzle. Blurry edges, jumpy details, yikes. Enter GIGA-ToF, a revolutionary approach that's rewriting the rules. Instead of focusing on depth values, it analyzes graph structures, a map of how pixels connect. Even if depth changes between frames, these relationships stay stable. Imagine tracking a teapot in a video. The overall shape stays consistent, even as it moves. Here's the breakthrough. GIGA-ToF uses geometric attention, a technique that highlights critical pixel relationships across frames. It's like a spotlight zeroing in on object edges while ignoring noise. This lets it smooth static without blurring details, giving depth maps a superpower to cut through chaos. What makes this work? It's not just speed or accuracy, it's temporal consistency. By leveraging stable graph patterns, GIGA-ToF avoids jitters and blurs. And here's the kicker. It thrives on real-world data, not just lab conditions. So next time you see a 3D scan or a robot navigating a room, remember, algorithms like GIGA-ToF are cleaning up the noise, making the digital world clearer. Stay curious, the future of depth sensing is brighter than ever. To test GIGA-ToF's power, researchers used the DvToF dataset, which simulates real-world depth images. They added artificial edge noise to mimic challenges like shiny surfaces or distant objects. The goal? Restore clarity without erasing details. The results? Let's break it down. The top row shows the ground truth, what depth data should look like. Below are 4 techniques: WMF, DVSR, MTDNet, and GIGA-ToF. The second row reveals error maps, where brighter areas mean more mistakes. GIGA-ToF shines here. While others blur edges or miss subtle textures, it preserves fine details, like the grain of a bookshelf in zoomed-in sections. It adapts to noise dynamically, acting like a smarter filter that knows when to sharpen or soften. Why does this matter? Cleaner depth data fuels advancements in VR, robotics, and autonomous systems. Imagine a self-driving car navigating a crowded street, or a VR headset creating lifelike environments. These rely on crystal-clear depth information. GIGA-ToF isn't just removing noise, it's teaching algorithms to recognize what matters. Next time you see a crisp 3D image, you might be witnessing GIGA-ToF's work. It's turning messy data into clarity, pixel by pixel. Thanks for watching, and let's keep pushing the boundaries of what depth sensing can achieve.